Hi, welcome back. Over the past bunch of videos, we've been talking a lot about atoms and isotopes and atomic mass and all these, I guess, different concepts. And I guess I'm starting to realize I haven't really given you a good representation of just what the size of an atom is, about how small an atom is. So what we're going to do in this video is I'm going to try to give you a good idea of how big an atom is, about what is how tiny an atom is. And in order to do that, we're going to take a look at copper. So copper is its atomic number is 29 on the periodic table. And I'm actually going to go up and get Wikipedia. And copper, this is just the copper entry on the Wikipedia page. And copper, what we're going to look at is the atomic radius. So copper has an atomic radius of 128 picometers. So its atomic radius, I'm going to say atomic radius is 128 picometers. So that means, if you remember from kind of our old video or our previous video, we said that, you know, it's almost hard to define where, like, the boundaries of an atom, because we've just got this, you know, we've got this tiny nucleus that's 1/10,000th of the space of an atom, and then we've got sort of this cloud that is almost just, it's really just a probability distribution of where we might be able to find an electron that is sort of attracted to the nucleus of this atom. So it's almost hard to define what the radius of an atom is, and you know the way we essentially do that is by saying, well, where is most of the probability of being? Where is the almost? You can't say that it is 100%, but where is almost 100% of the probability of being able to find an electron in this cloud around our nucleus. And for copper, it's not exactly, we'll definitely talk about this more in future videos. For copper, it's not exactly the spherical cloud. It actually has some really, the orbitals for copper actually have some very interesting shapes, but so they're not necessarily this exact spherical cloud. But for our purposes, what we're going to talk about in this video is essentially we're going to say, if we say that this amount enclosed by this kind of green circle, and I've sort of got these blue shades on the inside, if this represent really close to 100% of the probability of where we'll be able to find our electron, then this distance from our nucleus to the side of this circle, and this should be a perfect circle, I didn't draw it right, but this distance is going to be 128 picometers. And copper, when you put it together, again, this is, you know, it's copper, it's interesting the way copper fits together, but the way we're going to think about copper fitting together in this example to talk about how small an atom is we're just going to imagine copper atoms that essentially just line up, that just sort of line up with each other more or less in a straight line. And that is kind of more or less the way copper actually does line up in real life. So anyway, our atomic radius of copper is going to be 128 picometers. And therefore, we can say, what is the diameter? What's the diameter of our entire copper atom? Well, it's going to be 128 times 2, right? So what's 128 times 2? That's going to be 256 picometers, right? So this is the diameter of one copper atom. Now, you might think, you can think, what is something that we know that is made of copper? And if you're, I live in the United States, and I don't know exactly where you are watching these videos, but a penny is made out of copper. If you don't know what or if you're from a country other than the United States, a penny is our 1 cent coin. It's about the size of, it fits almost exactly on the pad of my pointer finger, I guess. That's about the size of a penny. It's the size of the head of the top of your pointer finger. And this distance, so the diameter of a penny, so the distance across a penny, let me get a better color, get blue. So this distance, the diameter, draw that better, the diameter of a penny, that distance is 19.05 millimeters. That should be a 9. 19.05 millimeters. So now let's figure out how many atoms is this. How many atoms, if they're all directly, and we can't say that they're all going to be exactly lined up in exactly a row right across the penny, but how many atoms are in this exact line? If we lined up atoms to go, from this side of the penny to this side of the penny, how many atoms would that take? And in order to do this, I'm going to use something, and I haven't really given you too much of an introduction to this before, but we're going to be doing dimensional analysis, which is essentially we're going to be converting a bunch of different units, and to do that we'll be using conversion factors. And if you don't know what that is, don't worry, we'll definitely talk about it probably in the next few videos. But that's what we're going to be using in order to figure out this problem. So we know that this penny, the diameter of this penny is going to be 19.05 millimeters across. And again, that's about the size, that's about the distance to go from one side of your pointer finger to the other side. So this is going to be 19.05 millimeters. And what we want to do to this number, because we have, I guess, our common form of figuring out how many atoms that is, because one atom is going to be 256 picometers. And again, it's a good thing to remind yourself, what's a picometer? If we wanted to write this in meters, how would we write this? This would be 256 times 10 to the minus 12, right? And hopefully you wrote that down from that table from the previous video on the standard units multiplier prefixes. But to say I have 256 picometers, that's the same thing as if I said I had 256 times 10 to the minus 12 meters. So anyway, we can pretty much figure out, let's say we were going to divide, let's first get our 19.05 millimeters in terms of meters. How many millimeters are in 1 meter? And this is sort of the first step of my conversion factor, is always to get it into a form where all of my units cancel out. So I have 1,000 millimeters in 1 meter. So pretty much, hopefully you can see, if I multiply this through, I now have my distance, my diameter of a penny, in meters instead of millimeters. So if I divide 19.05 by 1,000, I now get, you can imagine what I would get. I would get 0.01905 meters, right? And then the important thing to realize is that when I do this calculation, my units will cancel out. My units of millimeters will cancel out, and I'll be left with meters. So that'll be the new unit on my measurement. So anyway, we've got 19.05 millimeters is the diameter of a penny. 1,000 millimeters is equal to 1 meter. So in other words, what I'm doing here is just multiplying by 1, and that's an important characteristic of a conversion factor, and we'll talk about that more in the future. So essentially, we're just multiplying by 1. The next thing we want to do is we want to convert this figure into picometers, right? Because that's what we have the diameter of our copper atom in. It's in picometers. So we're going to multiply this, and we say that 1 meter. So when we multiply this, these two units of our meters will cancel out. That 1 meter is going to have 10 to the 12th picometers in it, right? Because that's how many, that's the division of how many picometers are in 1 meter. So when we multiply this entire thing out, we will get this distance. We will get this distance across our penny in picometers now. So that's what we figured out up to this step. So we started with our yellow step of our diameter of a penny in millimeters. And once we've completed this calculation, we now have this same diameter, but now it's in picometers instead of in millimeters. And so now we've really just got one final step left. We have to figure out how many atoms is this distance. So at this point, we've got how many picometers it is to get across this penny. Well, all we have to say is that one atom has a diameter of 256 picometers. So when we compute this completely, when we compute all of this, all of our units are going to cancel out. And again, if you don't quite understand this right now, that's fine. We'll definitely talk about it more in the future. But the important thing to realize is that all of our units, so millimeters and millimeters cancel out, meters and meters cancel out, picometers and picometers cancel out, and we're just left with the number of atoms it takes to completely traverse this line. So the number of atoms that it takes to completely fill this line across our penny. So let's go ahead, and I'm going to get out my calculator. Get out the calculator, clear it. So we say 19.05 millimeters divide by 1,000 is equal to 0.01905, which is what we thought it would be. And now we're going to multiply that times 10 to the 12th. And what I'm going to do is I'm going to use my EE key on the calculator. I'm going to do a video in the future about, I guess, more or less choosing an appropriate calculator for chemistry. But anyway, right now I'm going to use the EE key. So EE, raise it to the 12th power. That equals that. And then the last step is I just divide by 256. Divide by 256. And we get 74,414,062, you know, we can't have half an atom, but, and even, you know, how many significant figures do we have? We've got 4 significant figures here for the measurement of our penny, but we've only got 3 here for the measurement of the diameter of our copper atom. So we can only report this to 3 significant figures. So we can say that it takes 74.4 million atoms to make it across this penny. So let me write that down. That's going to be this distance. This distance right here, distance, is going to be equal to 74.4 million. 74.4 million atoms. And you can think that's how many atoms, if you had a penny, and a penny is made out of copper, that's how many atoms, if they were all lined up just right in a line right across this penny. And, you know, and again, this is just, it's only one atom, a 1 atom thick line across the center of our penny. If you had them all lined up, it would take 74.4 million atoms to make it from this side over here to this side over here. So anyway, hopefully that gives you a little bit of a sense of just how tiny an atom is, about just how many atoms, and you know, we'll definitely take a look at more atomic radii in the future, but we'll see that, you know, there is some variation on atomic radii and I guess atomic diameters, but you know, but this is a pretty standard size for an atom. So you can imagine, you know, just how many atoms comprise the whole penny. And we'll probably talk about this more in a future video, but I guess more or less the point of this video is to just help you realize just how tiny an atom is. That we have, in order to get from this side of the penny to this side of the penny, and just line up atoms in a straight line, we need 74.4 million of them to make it across this line. So anyway, I guess that's it for this video. Thanks for watching, and I'll see you in a future video.